Hello class, this is a video tutorial continuing on trigonometry and the unit circle part 2. In the previous video we saw how larger triangles are actually similar to to triangles that are found inside the unit circle, and how we could possibly calculate missing sides of trigonometry by hand. So I'm going to do another demonstration of this to hopefully get our understanding of this further. So we have this problem here. Let's try and solve this somewhat by hand. So to make sense out of this, we need to fit this, quote unquote, inside a unit circle. So let's draw one up. Here we go. Let's draw a unit circle only in the first quadrant. Let me just get this one here. Let's copy this, paste this. That is our unit circle in the first quadrant. Now we're going to copy this diagram and try and fit it, or just overlay it, of the unit circle. So 20 degrees, that's 45, 20 degrees, let's say it's about half, like so. So this length here should actually be 4.5. And then from there we're going to draw the perpendicular height. And we're looking for this length of x, really. It's on the x-axis. And that is 20 degrees. And then from here we can draw a smaller triangle from the unit circle, like so. And that has a radius of 1. And this length, this shorter one as well, we don't know what it is quite yet. But from the looks of it, it's very close to 1. Half is about there, that's half. 0.75. Let's say that's about 0.9. So cosine of 20 is 0.9. Because now when we draw that smaller purple triangle, it actually looks like this, where that's 20. That's a radius of 1. And this length here from the unit circle is 0.9. Now that larger green triangle, let's just copy that out. Whoops. Is the exact same figure enlarged. That has 4.5. We are looking for this value of b, or in this case x, that is also 20 degrees. Well, we can see that this triangle is the exact same triangle here, just enlarged, times by 4.5. We know this because it became 1 to 4.5. And because of this, we can say 0.9 times 4.5 will give us x. Let's test this out. 0.9 times 4.5, 4.05. Okay, so that there is supposedly a length of 4.05. Now if we follow this process using trigonometry, we can say that from this triangle we go cosine of 20 is equal to x over 4.5. And it'll be 4.5 cosine of 20 is equal to x. We can calculate that using a calculator. Cosine, so 4.5 or cosine 20, it's about 4.228, which, isn't too bad considering that we calculated this one by hand. So I hope you're really starting to see the connection between trigonometry, the Cartesian plane, and getting a deeper understanding of the processes that we're doing using similar triangles. Hope to see you in the next video. Best of luck.